Hello guys and welcome to another video. In previous videos I showed you how to develop different types of agent using LangGraph, including supervisor agent and React agents. Also you learn how to empower your agent using MCP. This video picks up where my last video left off. In my previous video I explained what are the main components of an online learning agent. An online learning agent is an agent that changes its behavior based on the way that user is interacting with it. So the agent customizes its behavior for every user. In this video, I want to show you how to implement the first component of an online learning agent, which is semantic memory. If you don't know what is semantic memory, I highly suggest you to watch my previous video. And for those who don't know me, my name is Homayun and I opened this channel to help you to be updated with recent technology and show you how to implement them efficiently. So if you're not subscribing me, it's your lucky day. Now you found me. Please push that subscribe button and let's begin the video. The agent we're going to develop in this project is a customer support agent. Our multi-agent system begins with a triage agent. But what is a triage agent? The role of triage agent is to classify the input query. When user asks something, triage understands this query is belong to which of these sub-agents and send the request to that specific agent. Now let's imagine the triage agent send a request to the return refund agent. Return refund agent use MCP server, call the tool and respond the query. But when we're gonna use the memory? If you remember from my previous video, there are two main ways in order to save the memory, to keep the memory. Background processing and hot pass updating. And the system design you're looking at right now is using the hot pass updating approach. In this approach, we pass the memory as a tool, along with other tools. We define two different functions for it. One for saving the memory and one for retrieving the information. So now whenever agent feels like there are some information that needs to be saved in the memory, or there are some information that are missing, and in order to respond to the query we need those information, agent use the retrieve function to retrieve the information from the memory and then respond to the user. So this is the agent you're going to develop today. Just guys, because lack of the time, I'm not be able to develop these two agents. However, the way that you develop them is exactly same as the return and refund agent. The only thing that is different is the way that you define the tools and the way that you define the prompt for that agent to give the role. And that's pretty it about the system design. I think I explained everything. Let's jump to the coding part. Okay, first thing first, we need to install the requirements. And since I already installed everything, it's not going to update anything on my environment. Then we need to define a config file to load the environment variable and the OpenAI API key. This helps us to have a clean code. Now let's create our agents. I'm going to create a graph folder here. And inside this graph folder, we're going to have nodes. These nodes will be triage node and a React agent, which in our case is the return and refund agent. Before starting developing any of these agents, we need to define a graph state. State in the graph is the history of the messages, is the way that one agent is passing the query, the messages to the next agent, which in our case, we have ticket input, which is the query of the user, and the messages that is a list of all the history inside the entire graph. Now let's develop different parts of the triage agents. The first part is the prompts, which are the system prompt exists in the triage agent. And this prompt explains to the triage agent that you should classify the input query in 3 different classes that exist here. And the agent instruction part is a part that exists, but we're gonna use it for the React agent. The next thing for the triage is an output parser. An output parser, it works like a guardrail for the LLM, and the way that LLM is generating the response is exactly in the way that we define. This is the parser that we're gonna use for our triage agent. We need a classification part and we need a reasoning part to understand, to monitor somehow the reason that LLM is generating this response. Now let's jump to develop the triage node. This might look a bit complicated for you, but I will explain you every little part of this code. Just before anything, remember to have an init file in every folder that you're creating. In this way, you don't have the problem for finding the paths. Just one more thing is left, and that is the prompt templates that we will use for our agent. These two are the prompts that we will use for our triage part. As you see, it's a triage system prompt and a triage user prompt. There are some parts in this that we need to fill when we are defining our triage node here. And in this way, the triage understands that how to use different agents and how to classify the input query. Now let's go to the triage and understand what is happening in this node. So, in the first part, we are going to define the LLM. And this is the LLM with the output parser that we already defined in our triage part. This is the triage output parser. After triage router, we have our system prompt and user prompt. And we need to fill them based on the data that we already added to our prompt instruction and the data that we have in our data section. Since I'm not connected to any database and I'm not using any database for this project, there is some dummy data here that I'm using to pass to the user prompt. After passing the values to the prompts, we will invoke the LLM. We run the LLM and we pass those two different prompts along with the role, which is system and the user, to the LLM. The output of this LLM call, the result variable will be either return and refunds, billing, or general. Exactly same as the way that we defined in our output parser. So when the input query belongs to the returns and refunds, we fetch the message of the user through the state and we send it to the response agent, which is going to be our React agent. And if it's a billing agent, we go to the billing agent. And if it's a general agent, we go to the general agent. But as I mentioned before, I'm not going to develop these two parts. And our focus here is just on the return and refunds agent. Now it's time to develop our React agent. The reason that I say it's React, it's reasoning and acting agent, is the way that inside LangGraph documentation, they define these types of agent. We define a function here named createPrompt, and we pass the agent instruction along with the state of the messages, which is the history of the message. So agent knows what it should do, and it has access to all the messages that exist inside the history. Another thing that also we should define here is the agent system prompt. So we go back to the prompt templates, and this is the agent system prompt we're going to use for our React agent. Before explaining you the rest of this agent, I'm going to create the MCP, because as you see, the MCP is being used here, but I need to show you how to build that part first. Inside the graph folder, you need to create two different files, MCP client and MCP servers. For the MCP client, we pass the SSE to the transport because we want to stream the responses, and we pass a URL which is the URL that we need to connect our client to the server. Also, before I forget, you should define a memory file and call the store, the in-memory store function, in order to pass the embed from the OpenAI or any other LLMs that you want. Because when you are saving the memory, it's not just saving a list of the memory, it's embedding the memory and then retrieving that using the vector similarity search. The server includes our tools, and these are some dummy tools that I already defined here: response ticket, schedule callback, check ticket statuses. But these two tools are super important: manage memory and search memory. These are the tools that allowing our agent in order to save or retrieve information from the memory. Now let's go back to our React agent, and as you see, we define it as an async format, and we define our MCP tools and pass it to the agent. If you don't understand how you should define this MCP part, I really suggest you to watch my video about developing the agent using MCP. In that video, I completely showed you how to define MCP step by step. Now that we have our nodes, our state, MCP server and client, and memory, the last thing that we need to write is the code for the main graph and connect everything together. So here we pass the state, the triage router as a node, the response agent, which is the React agent we already defined here, and we compile the graph, and we pass the input and the config to the function. And what is config here is the ID that we are passing for a specific user. I will show you here in the main file that how to use the config and pass it to your customer support agent here. So the first thing that we do is calling the function and the data. The second thing is using the config, which here is just a user ID, and we pass the config here into the function, and then we print everything like this. It understood the class of the query, but we have an error. What is this error? Remember, we defined the server for our MCP, but we never run this server. Let's run it now. So here we say Python MCP servers.py. And here you go, our MCP server is running. We go back here, we restart the kernel, and we run our main file again. It's checking all the tools and see which tools it's needed to call. And there you go. Let me close this and show you the entire history. So what's happening here is that the human is asking for returning an item, which is the shirt, blue shirt, size M. And the AI message is responding to that ticket in a way that agent is responding is using the response ticket, and then it's using the manage memory in order to save the information about that specific user. And if you see that, this is the message that agent is returning to us, not to the user, that is responded to this person and also saved information about Alex for the future references. And this is the way that you can create an MCP powered long-term memory for your agent in order to save everything that you want in your memory. And this was the semantic memory. In my next video, I will show you how to create an episodic memory and all your few shot prompts change dynamically based on the way that user is interacting to your agent. Thank you for watching this video. I hope that this video was useful for you, and see you in the next video.